Hello, Math 120 students. I am looking at this permutations and combinations. We know a little bit about factorial, and we're getting ready to count things. And we're going to be comparing permutation and combination. So let's look at the definition. A permutation is an arrangement of objects in a specific order. And what we say is that order matters. For example, awarding a first place, second place, and third place to a group of 10 students in a spelling contest. The order matters because I'm sure if you awarded the first place randomly instead of to the actual first place winner, that first place winner would not be too happy. So this is kind of a ranking. Whenever you have a rank or a ranking, a permutation is what we're looking at. Now, a combination is an arrangement of objects in any order. Order doesn't matter. Example, choosing 3 students from a group of 10 students to participate on a team. That order doesn't matter. You just pick any 3. All right, so let's take a look at these problems. We're going to do examples 11 through 16 here. And all we're going to do is decide if the order matters or it doesn't. So I'm going to look at this permutation, order matters, combination, order doesn't matter. And if I flip this over, I'm going to look at number 11, and we're just going to say if we have a permutation or a combination. So I'm looking at the very first one. I'm getting organized over on the side here. Ooh. And the first one says, suppose that 7 people enter a swim meet. Assuming that there are no ties, in how many ways could the gold, silver, and bronze medals be awarded? Now, gold, silver, and bronze, that is a ranking. So that's a first place, second place, third place. So that means that order matters, and we have a permutation. So what I'm going to do for number 11 is just put P, and then we'll calculate it once we learn how to calculate a permutation and we learn how to calculate a combination. So 12 says, that's all I'm going to do right now, permutation or combination. In a horse race, how many different finishes among the first 3 places are possible if 22 horses are running? So how many different finishes? Now what that means is first place, second place, third place, the first 3 places. Does order matter? Yes, first place, second place, and third place matters, especially if you're betting on that race. So, and what you do in these problems is you first decide if it's a permutation or a combination, and that's what I'm doing now, and then we do the calculation. Number 13. John bought a machine to make fresh juice. He has 5 different fruits: strawberries, oranges, apples, pineapples, and lemons. If he only uses 2 fruits, how many different juice drinks can John make? So now order doesn't matter. He could make a strawberry, orange, orange, strawberry, and that's the same thing. So in this case, order doesn't matter, and we just call this, in the math world, a combination. 14. How many different committees of 3 people can be chosen to work on a special project from a group of 9? So that's any 3. So is that permutation, combination? Does order matter? Order does not matter. So this is a combination. So when you're looking for a permutation, you're looking for a ranking. Number 15. From a committee of 10 people, how many ways can you choose a chair, a vice chair, and a secretary? That's ranking. If somebody's chair or vice chair, that's like president or vice president, and a secretary, that is ranking. So that is a permutation. And the last one, number 16. From a committee of 10 people, how many ways can we choose a subcommittee of 3 people? Here it doesn't matter. There's no ranking. Any 3 is fine. So that would be number 16 is a combination. So I'm just telling you, first you have to identify if you have a permutation or a combination. We're going to come back and find a number associated with that